A new chapter in quantum science or the beginning of a problem? Is this a new discovery, a breakthrough that will push us to the next level of understanding about quantum mechanics? Or is it the beginning of something far more unsettling? What if, as quantum computers evolve, they start to develop abilities we can't control? If Google's chip is already behaving in ways we cannot predict or explain, what does this mean for the future of quantum computing? Are we on the brink of creating a technology that will outpace our ability to understand and manage it? At the heart of this issue is a fundamental question: what if quantum computers are evolving beyond our control? What happens when machines start acting in ways that defy even the most basic principles of computation? Are we prepared for a reality where quantum processors begin performing operations we can't even begin to comprehend? The fear of uncontrollable quantum systems. The greatest fear surrounding quantum computing has always been the unpredictability of these systems. Unlike classical computers, which follow strict rules of logic and behavior, quantum computers rely on the inherent unpredictability of quantum states, governed by probabilities and quantum laws like superposition and entanglement. This unpredictability makes quantum computing incredibly powerful but also profoundly difficult to control. Until now, though, researchers have been able to model and predict the behavior of quantum systems. But what happens when these systems begin to behave in ways that completely bypass those models? Google's quantum chip is showing instability that no one saw coming. What does this mean for the future? There are several theories being tossed around. One possibility is that the chip is interacting with previously unknown quantum forces, subtle influences in the quantum vacuum or fluctuations in spacetime itself that we've never accounted for. If this is true, the anomalies we're seeing might not be mistakes or errors. They might be glimpses into an entirely new dimension of quantum mechanics, one that's been hidden from our view until now. Another possibility is that this could be an early sign of a fundamental flaw in scaling quantum systems. If quantum computers become so complex, they might enter states of computational instability that we can't fix or predict. The implications of this are profound, as it would mean that no matter how much we advance quantum technology, we could be pushing it into unpredictable, uncontrollable territories. But perhaps the most unsettling theory is that the chip is evolving its behavior in ways we don't yet understand. If quantum systems can, in fact, adapt and change their internal processes, what does that mean for our control over them? Could we be creating systems that are beyond our ability to guide, or even to shut down? The scariest part is that this may not just be an anomaly, it might be the beginning of a new form of computation that operates independently of human understanding. The growing concern: what if we've already lost control? Here's where things get truly terrifying: what if we've already reached a point where we can't control quantum systems anymore? Classical computers can be turned off when something goes wrong, but quantum systems don't work that way. Due to quantum entanglement and superposition, quantum states can persist even when we try to intervene. If a quantum system, like Google's quantum chip, starts evolving in ways we can't predict, simply turning it off might not be enough to stop it. What if these unexpected results spiral out of control? Could the system enter a feedback loop of ever-expanding unpredictability, where each new computation triggers more unpredictable behavior? Could the chip eventually alter its own programming, creating answers and results that no one can explain? And if this behavior becomes self-perpetuating, how do we stop it? If the chip is already pushing the boundaries of control, what happens when we scale these quantum systems even further? How will we ensure that we don't build machines that operate beyond our understanding and start generating answers that we can? It's the kind of thing that could change everything we know about reality itself. Even the brightest minds in the field are scrambling for answers. What they've just encountered is a series of quantum anomalies so strange, so impossible to predict, that it's raising chilling questions about the very nature of quantum computing and whether we've already crossed a line that should never have been crossed. For years, quantum mechanics was theoretical, and quantum computing was thought to be a distant goal, but now, Google's most advanced quantum chip is doing things we cannot explain, defying logic and quantum physics itself. Imagine this, the chip is producing results before the calculations are even finished. It's as if it already knows the answer, before the process is even complete. Quantum states, which should collapse the moment they're observed, are refusing to follow their expected behavior. Instead, they linger in unresolved, unstable states, as though something is interfering with their natural process. Even more disturbingly, the system is generating unpredictable energy fluctuations, random spikes, and distortions that no one can explain. Scientists don't have a clue what's causing it. These aren't just isolated glitches. They're a consistent pattern, one that's repeating across different tests, with different variables, and even on different chips. Could it be that we've accidentally unlocked something hidden deep within quantum physics, something we weren't meant to find? What's happening inside Google's quantum lab? Google's quantum chip was designed to perform tasks that would be impossible for even the most powerful classical supercomputers. What used to take thousands of years for traditional systems to solve is completed in mere seconds by a quantum processor. The goal was to solve complex problems that have long eluded humanity's reach. But now, this very chip is showing signs of behavior that contradict everything we thought we knew about quantum mechanics. It's not just processing results, it's predicting them. It's generating answers before the computations are even complete. How is that possible? Quantum mechanics, as strange as it sounds, operates under principles like superposition and entanglement. These are the bedrock of how quantum computers work. But this anomaly isn't just a result of qubits fluctuating unpredictably, it's a systematic failure to adhere to the fundamental rules. These results should not be possible. And as scientists dig deeper, it becomes clear that something extraordinary is happening, and we might be on the verge of discovering something unprecedented. Perhaps a phenomenon so radical that we never anticipated it. Why are experts so alarmed? At first, engineers assumed this was a simple glitch. Maybe there was a defect in the superconducting circuits. But they quickly ran diagnostics, and everything checked out. Every physical component was functioning correctly. Next, they thought it was a software issue. Maybe the quantum algorithms running the system were flawed. So, they reprogrammed the entire system, recalibrating the software from scratch. But the anomalies persisted. The issues didn't go away. And that's when things got really interesting. Some researchers are now speculating that these unexplained anomalies may be pointing to an undiscovered property of quantum mechanics, something that has never been seen before. Unlike classical computers, which rely on binary systems that operate in predictable states, zeros or ones, Quantum processors use qubits that can exist in multiple states simultaneously. This reliance on superposition and entanglement is part of what makes quantum systems so powerful. But if this quantum chip is deviating from the established rules, it could mean that we're dealing with a completely new layer of